All right, chemistry kids, here we go. It's the third lecture in our session on part 3, discussion notes for the atomic atoms and periodic table. All right, so we're opening to the part where it says, not that, this, trends in the periodic table. All right, so trends in the periodic table, how it's kind of organized, where kind of everything kind of fits in, things like that. These vertical columns, the vertical columns go up and down. They are called groups and families. And what the groups and family can tell you on the periodic table, if you see them, if you get it, they tell you your number of valence electrons. Valence electrons. All right? So the ones I'm talking about that you can tell your valence electrons right away are all the tall columns. The D block and the F block, you can't tell, those vary a little bit. So don't just take that for everything. Take that only for the tall columns. All right, I can tell you your valence electrons. Your groups, your periods, which are your rows that go across, okay? What information does that tell you? That tells you how many energy levels it has. So obviously something that's in row 4 has 4 energy levels. Row 5, 5 energy levels, so on and so forth. All right? Ionization energy kind of works like this. Ionization energy is the energy it takes to hold on or get rid of an electron. So ionization energy is, the lower the energy is, the easier it is to get rid of an electron. The higher it is, the tougher it is to get rid of that electron. So on the periodic table, as you go from bottom to top, left to right, it increases. All right? So that means that the one that has the hardest, that's going to hang on to the electron the hardest, or the most with the most strength, would be go bottom to top, all the way over to the right, and it would be this element right here, fluorine, because remember, these noble gases right here, these inert gases, don't want to react. So this would be the highest or the hardest one to get rid of an electron from. All right, that'd take a lot of energy. And then, so as you go left to right in a row, bottom to top, it increases. Atomic radius is opposite of ionization energy. The atomic radius is as you go from top to bottom, right to left, oops, that increases. All right, and what atomic radius is that as an element adds electrons, okay, so say we're looking at this row, and this one has 2 valence electrons, and then this one over here has 7 valence electrons. As you add electrons, you also normally add protons. As you add protons, it holds on to those electrons more. All right, so as the atomic radius decreases, which is what's going to happen here as you go from left to right, decreases, it's going to hold on to the electrons more. So this one down here wants to get rid of the electrons, so therefore it's going to have the biggest radius. And this one right here, because it has more protons than ones on this side, than on the left side, than the right side. The right side one has the more protons. It holds on to those electrons more, and therefore has a smaller atomic radius. All right. Next one is electronegativity, and generally it goes like this. Same as your ionization energy. As you go top to bottom, bottom to top, sorry, left to right, it increases. And what is electronegativity? It's basically the way it wants to hold on to an electron. All right, so the higher the electronegativity, the more it's going to hang on to the electron. The lower the electronegativity, the more likely it's not going to hold on to the electron. All right, so those are the trends that you're going to work with, and we're going to talk more about in class and do some work on. Now let's label the parts of the periodic table. Here are the parts. All right, so we got to label all these things on the bottom here. So we got metals and nonmetals. All right, so how do we separate those? Well, on most periodic tables, there is a thick, dark line that goes through this section. It kind of stair steps all the way through like that. This side represents your metals, and then this side of the stair step represents your nonmetals. All right? And then the elements that I'm kind of Xing here, not every element, but some of these elements that are touching this border, the stair step, those are called metalloids or semi-metals, all right, or semiconductors, because they contain some metals, some nonmetals. All right, so we talked about metals, nonmetals, and we talked about where the semiconductors slash metalloids are. Those are our semi-metals. alkali metals are this whole first group right here that starts with hydrogen. Those are alkali, that's your alkali family. Your alkali earth metals are the second group right here, alkali earth metals. This group right here, the second from the last, this is your halogens. Halogens right here. And this last group right here is called your noble gases because they don't want to react with anything. They're noble. They don't want to do anything with anybody else. They're above everyone else, so to speak. All right. Sometimes they're called the inert gases too. All right. And then in the middle here, this whole D block is called the transition metals. All right. So this block in here is your transition metals because you transition from the S block to the P block through these. So these are your transition metals. All right. So there's your basic information and parts of the periodic table and what information you can get or what information you need to know definitely for the test for sure. So we'll do some more work with this in class. Hope this helped. I'll probably put some other videos up there too that might help you out. Hope you have a good one. Bye.